In this video, I'm going to find the Laplace transform of the functions that are appearing here. The Laplace transform of a function f of t defined for t greater than or equals to 0 is given by f of s is equals to the integral from 0 to infinity of exponent of minus st multiplied by f of t with respect to t. And the Laplace transform simplifies complex problems by shifting the domain of analysis from time to frequency. And this allows easier manipulation and solution of equations. So to find the Laplace transform using Matlab, the command that we used is Laplace. Then we put the function inside parentheses. And this returns the Laplace transform of f. By default, the independent variable is t and the transformation variable is s. So now going on to the first question here, where we have our f of t being equal to t. I'll click on the return key, then click on code. Here, the first step is to define our symbolic variables. So whatever sims t, and define the symbolic variable t there. Then I click on the return key. Then for the Laplace transform of f of t, which is equals to t, I will just call it f1. My first solution is equals to Laplace, then open parenthesis, then we put in our variable t there, and then go on and run. So we have the Laplace transform of f of t is equals to t is 1 over s squared. I now move on to the second question, the Laplace transform of exponent of 2t. So I'll call this one f2 is equals to Laplace, open parenthesis. Then this is the Laplace transform of exponent of 2t, so it's exp. Then open parenthesis, 2 multiplied by t. Then I go on and run. And we have the Laplace transform of exponent of 2t is 1 divided by s minus 2. I now go on to the third one, the Laplace transform of sine of 2t. Click on the return key. I'll call this f3 is equals to Laplace, open parenthesis, sine, open parenthesis, 2 multiplied by t. So for the Laplace transform of sine of 2t, go on and run. We have the Laplace transform there is 2 divided by s squared plus 4. I now go on to the next question, the Laplace transform now of the Heaviside function. And what we are having here, this is a shifted Heaviside function where the value of the a there is a positive. So we have to create a symbolic variable where we have a variable a where the variable a is positive. So I'll type in my sims there, then a, then specify that it is positive. Then go on and call it my solution 4, f4 there is equals to Laplace, open parenthesis, and we are finding the Laplace transform of the shifted Heaviside. So it's a Heaviside, open parenthesis, t minus a, where the a is a positive variable there. So we click on run, and we have the Laplace transform of the shifted Heaviside there is exponent of minus as divided by s. I then go on to the last question there, the Laplace transform of the derivative of a function y. So what I will do is I'll first have to find the derivative of the function, and to enter that derivative, I'll first have to enter a symbolic variable which I will call y of t. Then go on and write our derivative, which I call dy is equals to diff, open parenthesis, and we are differentiating the y of t, then comma t to say that's a derivative with respect to t. I can just run here so that you can see it's a derivative of the y with respect to t. So we have entered our derivative. Then now find the Laplace transform of this derivative. So I'll call that solution F5. So F5 is equals to Laplace, open parenthesis, and we are saying the Laplace transform of the derivative, which we've just called the dy. I can just click it here. Then you can go on and run. And we have the Laplace transform of the derivative of y is equals to s multiplied by the Laplace transform of the y, where we are having the independent variable being t and the transformation variable being s, then minus y evaluated at 0. So this is the Laplace transform there of the derivative of y.